Alright, this was a test on all conic sections. I'm talking circles, parabolas, ellipses, hyperbolas, the whole shebang, all rolled into one. Alright, for these first problems we need to draw a graph of each of the following conic sections and then identify the important characteristics. A few of you were skipping the graph part. You can't do that. Gotta draw the graph. First thing you need to do is decide what kind of shape you're dealing with. Which type of conic section? Is it a circle, ellipse, hyperbola, parabola? What's going on here? And to figure that out, all you really need to do is look at the x squared and the y squared term. Okay, first of all, if nothing is squared, it's linear. Maybe I'll just make a list. Alright, let me start with linear. It'll be linear if it's just nothing squared. If I just have x and y, nothing squared, that's linear. Let's see, it will be a parabola if only one of these things is squared. Like if it's x squared and then y, or if it's x and then y squared. If only one of them is squared, it's a parabola. Okay? Let's see. Let's go for circle. Okay, if it's a circle, a couple things are going to happen. First of all, you're going to have both things squared. Second of all, the coefficients, the number in front is going to be the same. Oh, and it's going to be positive, like this. So this would be a circle, alright, if it's just x squared and y squared. But also this would be a circle, 4x squared plus 4y squared. Okay, or 7x squared plus 7y squared. These are examples of circles. Okay? Alright, the x squared and y squared are both the same, and it has to be positive. On the other hand, if it's an ellipse, yeah. If it's an ellipse, it has to be positive still, but the x squared and the y squared will have different coefficients. So for example, if this was 3x squared plus y squared, or 2x squared plus 4y squared, 5x squared plus whatever, 6y squared. Okay, if they're not the same, has to be positive though. Everything has to be positive. Both things have to be squared. But if the coefficients are the same, it's a circle. If the coefficients are different, it's an ellipse. That leaves hyperbola. Whoa. Alright, the key thing about a hyperbola is one of them is going to be negative and one of them is going to be positive. Okay? So for example, like I could take any of these examples. Well, okay, I mean they both have to be squared. So say if I had x squared minus y squared, boom, that's a hyperbola because one of them's negative. Or if I had negative 3x squared plus 2y squared. Alright, if one of them is negative and one of them is positive, it's a hyperbola. It doesn't matter if they're the same or different or what. Okay, so I could have, 4x squared minus 4y squared. If one's positive and one's negative, regardless of if they're the same, like these are the same, or if they're different, like these are different, it's a hyperbola if you have one's negative and one's positive. Okay, still they both have to be squared. Only a line and a parabola, a circle, ellipse, and hyperbola all have x squared and y squared in it. Okay, so anyway, here's the breakdown. This is what I'm looking for as I decide whether it's linear, parabola, circle, ellipse, or hyperbola. Okay, so looking at this, what's this going to be? Looking at this equation right here. Hopefully you said, Mr. Burton, this is going to be a hyperbola, because I see that this one is positive and this one's negative. So kabam, it's a hyperbola based on what I said down here. Alright, I need to clean up this mess. Alright, so we know it's going to be a hyperbola. So this is the general look that we're going to be going for. Now we don't actually know whether we don't know whether the x term is going to be first or whether the y term will be first. Could be like this, okay, with the y here and the x there. We don't know yet, but this is the general form that we're shooting for. Alright, let me clean up this mess. So with that in mind, the way we make this happen is by completing the square. So we need to get our x terms together and our y terms together. It'll be a beautiful thing. Okay, so let's see. I'm going to put my y's out front because they happen to be positive right now. So I'm going to start with 9. Hold on. Let me make this a little bit smaller so I can fit more. Okay, so I'm going to start with my y's because they're both positive. So 9y squared plus 54y. Okay, I'm putting those together. Now here come my x's. Alright, I'm going to leave a little space here to complete my square. So I'll have negative 16x squared plus 64x. Again, I'm leaving a little space here. I'm going to take this negative 127. I'm going to add 127 to both sides. So I'm going to wind up with a positive 127 over here on the right. Okay, that's what happened, but I'm just going to go straight to this. Okay, now I shall complete the square. But not yet. Not yet. You can't complete the square when you have a coefficient sitting here. I'm going to have to bring that outside of parentheses first. Okay, so let's do that. So if I bring out this 9 like so, okay, that's going to leave behind y squared plus 6y, leave a space. And I'm going to do the same thing with this 16. Alright, I'm going to bring out this negative 16. Okay, always got to bring that out. And on the inside, that's going to leave x squared minus, alright, a negative times a negative is a positive. Let's see, I'm doing 64 divided by 16 right now. Okay, 64 divided by 16, that's 4. So minus 4x, leave a space. Okay, and all this is equal to 127 still. Okay, yeah, in case you're wondering like where the 6 is coming from, once I see I'm pulling out a 9, what I'm really doing is I'm dividing everything by 9. Okay, that way the 9's cancel, 54 divided by 9 is 6. Same thing here, I'm really dividing everything by negative 16. And that's why 64 divided by negative 16 is negative 4. Okay, probably the easiest way to think about it. Okay, now I can complete the square. Half of 6 is 3. 3 squared is 9. So I'm going to have a 9 there. Now, normally I would add 9 to this side to balance that out. But this is not really a 9. Because of there's this 9 out front that's ready to distribute, this is really 9 times 9, which is 81. So I really have to balance this change out with an 81. Same thing over here. Half of 4 is 2. 2 squared is 4. So I put a 4 right here. But I'm not going to put a 4 over here to balance it out. This is really negative 16 times 4. Okay, and I'm grabbing my calculator here. Negative 16 times 4 is negative 64. Okay, so I'm going to put a negative 64 over here to balance this out. Okay. Okay, negative 16 times 4. Okay, now I can rewrite this. Now, so you know the whole point of completing the square was so I could write this as the same thing twice. Okay, putting all this stuff together, let's see, 127 plus 81 minus 64. That is 144. Now this will be y plus 3 twice. Alright, you're guaranteed to get the same thing twice when you complete the square like this. So this will be x minus 2 twice. Okay, so that makes this 9 times, whoops, almost made an x. This is 9 times y plus 3 squared minus 16 times x minus 2 squared equals 144. Now, in standard form for hyperbola, I know I need a 1 over here. It's supposed to equal 1. So since I know that, then I know I need to divide by 144 everywhere. Okay. Now, let's see. How many times does 9 go into 144? So right now I'm doing 144 divided by 9. 144 divided by 9. That is 16. Okay, so that's why I'm going to have y plus 3 squared over 16. Well, guess what? That tells me that 16 goes into 144 9 times. So that's genius. So I'm going to have x minus 2 squared over 9. 144 divided by 16. Yeah, I knew that. And this is going to equal to 1. So kabam! This is the standard form equation. It is a thing of beauty. I'm going to copy it because I can. You're jealous right now because you have paper. When will we catch up with the technology? All of you should be working on tablets with electronic pens. Paper is already obsolete. I don't know what you guys are doing with pencil and paper. Alright, I think it's funny that we still have pencil sharpeners. Okay, let's get into the new century. Anyway, just dreaming out loud a little bit. Let's get on with it. The vertex, the center, not the vertex. The center of this hyperbola is going to be visible right here. It's going to be the opposite of these. Don't forget the x has to come first, so it's going to be 2 comma negative 3. See how I changed it? X comes first though. 2 comma negative 3 will be my center. So 2 comma negative 3. Okay, let's get that going on. Okay, so 2 comma negative 3. This is going to be the center of it all. Now, this is going to give me an a value of 4 and a b value of 3. Alright, now's a good time to pause for a second and take a look at what we're shooting for. This is sort of what the finished product might look like. This is a picture of a hyperbola. Sometimes a hyperbola will be sideways like this one, opening left and right. Sometimes it will be vertical like this one, opening up and down. Alright, a hyperbola has 2 foci or foci that sit on the inside of these branches. Now, we need to decide if it's going to open sideways or up and down. And the way you know is if the x term is the positive one, then it's going to be sideways. It'll open in the x direction. If the y term is the positive one, out front like this, then it's going to open in the y direction, up and down. Also, just notice as far as the what I'm calling the A and the B, please notice that for hyperbolas, A is not always the biggest. Okay, the A value is always going to be where the vertex is. It's always going to be the distance from the center to the vertex. Okay, so if it's a sideways parabola, the A value will be sideways. Anyway, the point is it's not always the biggest. That's all you really have to worry about. So in this case, because the y term is squared, because the y term is positive, it's out front like this, we know that this is going to be an up-down hyperbola. It's going to be vertical. Okay, do we get to say that? I guess we don't list that anywhere, but just know that it's going to be vertical. So anyway, so A is, if this is a squared, then A is 4 and B is 3. All right, again, whatever I'm calling the A value, it's always going to be the positive one for a hyperbola. Not necessarily, it didn't have to be the biggest. Anyway, part of how you draw a hyperbola is you start by making a rectangle. Okay, you're going to use your A and B to draw a rectangle. So that's what's going to happen right now. So you know, my A term, I need to change colors. A is 4. No, I'm not going to change colors. A is 4, and notice that the A, the 4, is with the Y. So if it's with the Y, you do it in the Y direction. All right, that's for all the shapes, whether it's an ellipse or a hyperbola. So I'm going to go up 4, 1, 2, 3, 4, and I'm going to go down 4, 1, 2, 3, 4. Okay. Now my B value comes from this 9, which is with the X. Alright, if it's with the X, you go in the X direction every single time. So I'm going to go 3, but I'm going to do it in the X direction, left and right. Okay, so this shows you where the rectangle is. Alright, there's your rectangle. That's going to be very important. Now, the diagonals of this rectangle will form asymptotes. Okay, that will show us where the branches belong. So I'm going to draw diagonals through this rectangle right now. Alright, so here are the asymptotes. Okay, now the branches. Now remember, we looked and we saw that if the y term was positive and first, then it was going to go in the y direction like this, up and down. That's important because that tells us to draw our branches in the top and in the bottom. So let's go ahead and do that now. And there it is. So that's what your graph should look like, just like that. Okay, now let's get the rest of this going on. So the vertices are these points right here. Okay, here's a vertex. So that is what? 2, -7 is one of them. And this is going to be the other vertex right here. And that's 2, 1. Alright, those are the two vertices. Okay. The co-vertices are not actually part of the hyperbola, but we can still name them. These are the co-vertices over here, and they are -1, -3, and 5, -3. Those are the co-vertices. Now the foci, or foci, they're going to be floating around in here somewhere. To figure out exactly where, we need a third value. You know, we have our A and our B. Guys, we need a C value. And the way we find that is for hyperbolas, the relationship is c squared equals a squared plus b squared, just like the Pythagorean theorem. So let's do that right now. Let's see, do I have space down here? I'll just do it right here. Okay, so c squared is equal to a squared plus b squared. That means c squared is equal to 16 plus 9. That means c squared is equal to 25, which means that c is equal to 5. Okay, now that c value is the distance from the center to the focus. So this is 4 right here. 1, 2, 3, 4. So if I go up one more, you know what, let me use an actual little circle here. Alright, that's a little too big, huh? Yeah, that's a great focus. So that will be the focus right there. Okay, and of course if I go 5 in the other direction, okay, that will be my other focus. Okay, so I have a focus at 2, 2 and 2, -8. Alright, now it's time to find the equations of these asymptotes. I'm not quite sure why it says use the space below to show the work, because there really isn't any work to show, at least not the way I do it. The equation of the asymptotes, there's two of them, that's why there's plus or minus, right? It's really two different equations, but it's always just going to be y minus k is equal to plus or minus the slope times x minus h. Now, this y minus k and x minus h, exactly what am I talking about again? Well, if you look at the equation, I'm talking about this. Okay, this right here, without the squared on it, this is my y minus k, and this is my x minus h. These two things are always going to show up in your asymptote equation. Okay, so all we really need are the slopes. So what did I have right there? Was that y plus 3? I thought I saw. So I'm going to have y plus 3 is equal to plus or minus the slope. Alright, I'll change that in a minute. And what was it? X minus 2. Okay, so we're always going to have those same two things that showed up in our equation. All we need to worry about is the slope. So just pick either one of these lines. I usually just look at the positive one. And just look, what's the rise and the run? Okay, so as I go from, like look at the corner. As I go from the center to the corner, I'm going up 1, 2, 3, 4, and over 1, 2, 3. So that's 4 over 3, rise over run. Okay, so that's your slope. Okay, so it's plus or minus 4 over 3. Now again, the plus or minus is because we have two equations. This one is the plus 4 over 3, and this one going downhill is the minus 4 over 3. Okay, but that's the only difference between those two equations. And there you go. So I think that's it for this problem number 1. Let's move on to problem number 2. Okay, so first of all, which kind of shape is this going to be? Yeah, I feel a parabola coming on. Alright, this is a parabola. How do I know that? Because only one thing is squared. Alright, the y is squared, the x is not squared. That's a parabola. Plus, it's in standard form and everything. Let's see. Is this going to be a parabola that's up and down, or will it be left right? Well, when the y is squared, all right, that's unusual. When we first learned about parabola first one we ever saw was y equals x squared. That was definitely an upward facing parabola. If this was negative, then it was down. Okay, when the x was squared, it was normal like this. So if the y is squared, that's unusual. That means it must be sideways like this. Either like this or like that. One or the other. Not both like a hyperbola. Now, which one is it? Well, let me get rid of this garbage. It depends on the sign right here. If this is the positive version and this is the negative version. So because I've got the -8, I'm looking at this. Okay, so it's facing to the left. I think I get to write that down somewhere. Nope, not today. I'll just write it down right here. Serves you right. So it opens to the left. Anyway, it's already in standard form. So the vertex, now do not get it backwards. You have to start with the x. So it's the opposite of this and the opposite of that. So +3, -2 in that order. +3, -2. So there's your vertex. Let's go ahead and graph that up. +3, -2. That's my vertex. Okay. Now this -8's sitting right there. There's 4p that is equal to this number always, and if I divide both sides by 4, don't you know? Okay, that tells me that p is equal to -2. Now, what that tells me is where the focus goes. I'm going to the left. Now I know to go to the left 2. That's what the point of that is. So this is the vertex, and I'm going to go to the left 2, and that'll be my focus. You know, so it'll be, my focus will be right here. But you know what? I feel like using one of these circles here. I'm going to borrow one to use as my focus because they look kind of cool to me. I think I'm going to do that from now on. Okay, so I got my vertex and my focus. So I know my parabola is going to be wrapped around this like that. Anyway, also the directrix. Parabola has this vertical line called, well, it's not always vertical, but there's this line called a directrix that's in the opposite direction from the focus. So the focus was 2 to the left, so the directrix will be 2 to the right. Okay, so my directrix will be right here. Okay, there's my directrix. Okay, feel like I better write down the stuff I have so far. So I've got the vertex. The focus was 1, -2. The directrix, vertical lines are always x equals a number, and this is x equals 5. Now the focal width is always positive. Okay, see that -8? So the focal width is 8. Now what that actually tells me is at the focus the parabola is 8 wide, so that means 4 up and 4 down. So that means I'll have a point here and here, and that's enough to show me where the parabola is going to be. And there you go. That is what your parabola should look like. Alright, I think that was it for number 2. I think we did everything that we had to do. Alright, let's move on to number 3. Alright, same deal. So which type of shape is this? This is going to be an ellipse. I know this because everything is positive. Alright, both terms are positive. And it's as far as my x squared and y squared, but the coefficients are different. If these were both 4s or both 9s, that would be a circle. Since they're different, it's an ellipse. So just, you know, good to know. No, as far as like, let's look at some notes real quick. An ellipse, okay, we're talking about this. So look at these little equations here. So this is the general, the shape of what the equations kind of look like, except we'll be doing x minus h and a y minus k type of a deal. For ellipses, we always call the bigger denominator a. Okay, that wasn't true for hyperbolas, but that's how it goes for ellipses. We always do x first, then y. Okay, that's all you need. That's all we need to know for now. I'll come back to this for other stuff. So we need to complete the square again. So let's do that real quick. All right, so my x's. So here I go. I've got 4x squared, and then minus 8x. I'm gonna leave a space, and then I've got 9y squared, and then plus 72y. Okay, I really want to subtract 112 from both sides. Okay, so these will cancel out. For that reason, I'm going to have negative 112 over there. I still cannot complete the square just yet because it's 4 here. So what I need to do is I'm going to pull that 4 outside of parentheses, you understand. And that's going to leave behind x squared minus 2x, leave a space. Same thing here, I'm pulling out the 9. That'll leave y squared plus 8y, leave a space, is equal to negative 112. Alright, if you are at all confused where I'm getting the 2 and the 8 from, just remember when I pull out that 4, I'm dividing by 4. When I pull out this 9, I am dividing by 9. Okay, 72 divided by 9 is 8. Negative 8 divided by 4 is negative 2. So, you're welcome. That just helped you out right then. Now let's complete the square. Half of 2 is 1. 1 squared is still 1. Yeah, normally I would put a plus 1 out here to balance this out. But I'm not going to put a 1 this time. Because this is not really a 1. This is really 4 times 1, because this number out here is about to do the distributive property. 4 times 1 is 4, so I really need a 4 to balance this out. Similarly, half of 8 is 4. 4 squared is 16. But I'm not going to put a 16 over here. I got to do 9 times 16. I don't know that off the top of my head. 9 times 16. That's 144. So I'm going to put plus 144 over here because of 9 times 16. Now I can clean this up. So this will be 4 times x minus 1 times x minus 1. Right? That's how this would factor down. And this will be 9 times y plus 4 twice. Okay, let's clean this up. So 144 plus 4 plus negative 112. That gives us 36 over here. So what we have here is 4 times x minus 1 squared, and then 9 times y plus 4 squared is equal to 36. Now, looking at your standard form, you see that we have 1 here, just like for a hyperbola, which means we must have to divide by 36. So let's do that. Let's divide everything by 36. Okay, you know 4 goes into 36 9 times, so I'm going to have x minus 1 squared over 9. And same thing here, 9 goes into 36 4 times, so I'll have y plus 4 squared over 4 is equal to 1. Okay, now this is the standard form, so let's go ahead and copy that down. Put it on the line where it belongs. Okay, so might as well just go ahead and mention, so this tells me that a is 3, and b is 2, alright, because it's a squared and b squared. Again, for ellipses, we always call the bigger one a. Yeah, so looking at this, we can know the center. The center is going to be the opposite of this and the opposite of that. So positive 1, negative 4. So 1 comma negative 4 is my center. Okay, so 1, negative 4, there's my center. Okay, now I'm going to do the A and the B. Now what matters is the A is with the X. So this 3 is going to be in the X direction. So I'm going to go 3 horizontally like this. Okay, and this B is with the Y. So I'm going to go 2 in the Y direction. So 1, 2. 1, 2. Alright, now this shows you where the ellipse is. So I'm just going to draw the ellipse. Alright, so there's your ellipse. Now we can talk about the vertices and the co-vertices. The vertices are always the long way. Okay, so the ends of the egg here are the vertices. So we have a vertex at -2, -4. And another one at 4, comma, -4. Okay, and then we have co-vertices the short way. So that's 1, comma, -2. Okay, and 1, comma, -6. Alright, now, as far as the foci always go the long way, and they are a C value, so we're going to need that C value again. Okay, so we have A and B. For ellipses, C squared is equal to A squared minus B squared, not plus like it was for hyperbolas. So here we go. So C squared is equal to 9, okay, A squared, minus 4, that's B squared. So C squared is equal to 5. That means C is equal to the square root of 5. Okay, and as a decimal, just to help us graph it, let's see, the square root of 5 is 2.2. Okay, so this C value is the distance from the center. Okay, so I start from the center and I go over 2 and change. Okay, so so that means I'm gonna have a focus here and a focus there. Alright, I wonder if I get those little circles from the other page. Yeah, so these little white circles here, those are the foci. Now as far as naming them, the what can I tell you? The Y values are obvious. Okay, you see that all of these points are at a height of -4. So there's no question that the Y values of both of these points are -4. So let's get that part done. Alright, we have two of these things. Okay, but we know that the Y values are -4. So it's going to be something, comma, -4, and then something else, comma, -4. Now the X value is the thing that we have to worry about. So what it is start with the X value of the center. Okay, the center is at an X value of 1. Okay, so this little guy, the X value is going to be 1 plus radical 5. Okay, because we started at 1 and then we went radical 5 to the right. And the X value of this little guy is going to be 1 minus radical 5. Okay? So think about it. So it would be like 1 plus 2.2, for example. So what is this? 3.2? See how that makes sense? Because look at it. Because here's 3 and change. So 3.2. Alright? In the same way, if we did 1 minus 2.2, what's that? 1 minus 2.2, that's negative 1.2. Does that make sense? Well, sure, because it's negative 1 and a little bit more. Okay, so if I was going to use decimals, then I would have a negative 1.2, comma negative 4, and positive 3.2, comma negative 4. But, you know, I rounded to get these numbers. I rounded. So it would be even better to put how we got this. We did 1 minus radical 5, and we did 1 plus radical 5. Okay, now length of the major axis. The major axis is the long way across from one vertex to another. So, so remember, this is 1, 2, 3, 1, 2, 3, total of 6. So the major axis is 6. The minor axis is 4. It's 4 the short way across. Okay, so that's genius. And I think that's all there is to that one. Alright, let's slide over and do the next one. Okay, number 4. Yeah, so what kind of shape is this? Yeah, this is definitely a circle. Alright, both the x and y are squared, it's positive, and the coefficients are the same. They're both 1. It's a circle. I mean, it's in standard form. This is the shape of a circle. In fact, the center is going to be the opposite of this and the opposite of that. X first. So 3 comma negative 1 is the center. Let's write that down. So 3 comma negative 1. Now, this is the radius squared, which means that the radius is 4. Okay, so yes, there's that. So center is 3, negative 1. Okay, so there's my center right there. And with the radius being 4 and all, that means if I go 4 in all directions, I should be on the circle. Okay, so there's your circle right there. Okay, there it is. And that might just be all there is to that. Yeah, I think that's it for that one. Alright, let's move on. Solve the system of equations. By God. Well, this one we should do by elimination. I see that we have opposites that cancel already lined up. Okay, these x's. In fact, both pairs of x's are set to cancel. So it wouldn't make sense. Sometimes we've set these equal to each other, but it's better to just leave these exactly like they are and just combine like terms. Because the way they are, these x's are going to cancel out. And these x's will cancel out. Alright, now if I put these y's together, y squared plus y squared, that is 2y squared. And negative 2y plus negative 2y is negative 4y. And negative 4 and negative 12, well, that's negative 16. And of course 0 plus 0 is 0. So very quickly I have this. Now, by the way, if I didn't have opposites, I could have just multiplied one of them by -1 to change the signs to make opposites. Anyway, I'm also noticing that all of these are divisible by 2. So let's do that. Let's divide everything by 2, including the 0. When it's an equation, we don't have to keep the 2 off to the side or anything. We can just divide. So this will leave us with y squared minus 2y minus 8 is equal to 0. Let's factor this if we can. So y squared can only be y times y. 8 is either 2 times 4 or 8 times 1. We know that the inner, which is 2y, and the outer, which is 4y, have to give you the middle, which is -2. So if I had a positive 2 and a -4, that would make -2y. So there's my positive 2 and there's my -4 that I was just discussing. Okay, so now to go ahead and solve this, we have to set these equal to 0. So if y plus 2 equals 0, subtracting 2 from both sides, we have y equals -2. Okay, if y minus 4 equals 0, adding 4 to both sides, I have y equals 4. Okay, so we have some y values. Now we need the x values that go with them. So what do I do? Well, I make a t-chart. That's what I do. Alright, so I've got x and y. Okay, so so far I've got these y values. I've got -2 and 4. So I want to find the x values that go with them. So what I'm going to do is I'm going to pick one of these original equations and I'm going to plug in -2 and see what the x is. So yeah, let's do that. So the first, I'm going to use the top equation here. So substituting -2 for y, that's going to give me x squared plus -2 squared, correct, because that's y, plus 4x. Okay, I don't know why it's plus -2. That was silly. Minus 2 times -2, and then minus 4 equals 0. So that's going to give me x squared plus 4. Okay, -2 squared is positive 4. Okay, plus 4x. -2 times -2 is positive 4. And then I have minus 4 from right there equals 0. Okay, now these positive 4 and minus 4, they cancel each other out. So just rewriting this in a normal type of a way. Right, I'm going to have x squared, and then plus 4x, and then plus 4 from that, okay, is equal to 0. So these just switch places. Now let's see if this will factor. X squared is x times x. Okay, 4 is going to be 2 times 2. Looking at the signs being all positive, it's going to be plus and plus. And sure enough, inner I have 2x, outer I have 2x. That gives me 4, so it works out. Okay, so fine, we just factored it. Setting these equal to 0, well, it's the same thing twice, but so setting this equal to 0, subtracting 2 from both sides gives me x equals -2. So, bottom line is, when the y value was -2, the x value was also -2. Okay, we need to do the same thing with the y value of 4 and see what happens there. Okay, so I'm just going to do the same thing again. Just leave myself plenty of space. So I'm going to do the same thing, except for instead of -2, I'm going to put a 4. So this is, I have space, so I'm going to put it up high. So I have x squared plus 4 squared, and then 4x minus 2 times 4 minus 4 equals 0. So that'll be x squared plus 16, okay, plus 4x minus 8 minus 4 equals 0. Alright, combining like terms. Okay, 16 minus 8 is 8. 8 minus 4 is 4. So I get 4 out of all this. So I'm going to have x squared plus 4x plus 4 equals 0. That's the same exact thing I had before, so I already see what's happening here. I mean, I really could have just stopped. Once again, I get an x value of -2. So when the y value is 4, you still got -2. Now this is a little bit of a coincidence. It's not always going to be the same x value. It just happens to be the same x value this time. But anyway, that's it. So these are the 2 points of intersection. Okay, these are the two solutions, -2, -2, and -2, 4. Okay, that is it. Alright, so that's all she wrote for problem number 5. Alright, let's move on to problem number 6. Write the equation of a hyperbola with vertices at 1, -7. Well, let's just do this as we go. Alright, so vertices at 1, -7 and 1, 3. Alright, if these are vertices of a hyperbola, that means it's doing this type of a thing. Okay, alright, the vertices are where the branches are. Okay, so this is an up and down hyperbola. That's what it tells me so far. Okay, it also tells me where the center is, because the center should be halfway between these. So look, this is 3 up, 7 down. It's a total of 10. So that means 5 should be halfway. So 1, 2, 3, 4, 5. So this is the center right here. And ladies and gentlemen, this center is, I'll just put it over here. The center is 1, -2. Okay, so that tells me a lot about this hyperbola. Because it's an up and down hyperbola, alright, going in the y direction, if you will, that tells me that the y term is going to be first. So I'm going to start off with a y. Also, because I have the center, I can know what will be with the y. So it'll be the opposite of this. So y plus 2. So I'll have a y plus 2 squared. Okay, and hyperbola is always minus. Okay, and then it'll be x. Alright, x minus 1. So the opposite of that. Squared. Okay, and I know it's going to equal 1. So now it's just a matter of what goes down here. Alright, so for that, I'm going to need, well, I already have one of them. Okay, so in the y direction, okay, from the center, like I said, this is 5. I feel like I should change colors real quick. Okay, this is my A direction. Okay, so I'm going to say A is equal to 5. It's the Y direction, so this is going to go with the Y value. That's what's important. So remember, this is A squared. So this is 5, so this is going to be 25 because I got to square it. So this will be 25. Now, all I need is the X direction. And that's what's coming up next, the covertices. So the covertices are at -3, -2. So -3, -2, there's a covertex. And there's another one at 5, -2. Okay, those are covertices. Alright, so that is going to give me that other value that I need. The B value, if you will. So this tells me that B is 4. Okay, notice this is in the X direction, so I know that it's going to go with the X value. Alright, but this is B squared, so this is going to be 16. And there it is. Okay, so let's move on to number 7. Alright, now an ellipse. Alright, let's sketch it as we go. Standard equation of an ellipse with foci at -4, 1. I've decided to always make my foci open circles because I don't know, I think it's cool. -4, 1 and +4, 1. Those are my foci. Now, just so I can do this as I go along, that gives me the C value. Well, first of all, it gives me the center. Alright, because the center of this ellipse will be halfway between these. So look, it's 4 to the left, 4 to the right. So the center is definitely right here. So I know that my center is 0, 1. Let me write that down. So center is 0, 1. Because this is my distance to a focus, then that is my C value. And my C value here is 4. Alright, so make a note of that. And let's see what else we have going on here. Oh, covertices now. At 0, -2. Okay, so 0, -2 and 0, 4. So these are my covertices. Now, because this is a covertex, I'm going to call that my B value. Okay, so this tells me that B is 3. Now, ladies and gentlemen, for ellipses, we know that C squared is equal to A squared minus B squared. Alright, you just have to memorize that. For hyperbolas, it's plus. For ellipses, it's minus. Okay, so I've got the 4 and the 3 here. So C squared will be 16. So 16 is equal to A squared. We don't know the A yet. Minus B squared, which is 9. Okay, so if I were to add 9 to both sides, so that'll give me 25 is equal to A squared. So taking the square root of both sides, that gives me A is 5. Okay, now A here is the distance to the vertex. So I'm already at 4 right here. So if I go to 5, then that's going to be a vertex. Okay, so why is all that important? Because, you know, I just OCD makes me have to draw this real quick. So stand by. Whoa. Okay, so there's my ellipse. Now, the equation of an ellipse works like this, my friends. You know, it's positive, always equal to 1. Now, x always comes first when we do an ellipse. Okay, now, and then the y comes second. So, the center, though, it's going to be, this will be my x and this will be my y. I'm going to do the opposite, though. So this would be like x minus 0 and y minus 1 from this. Okay, and now down here, again, you know, you don't have to worry about what's A and what's B. Just focus on the direction. So I'm just going to draw this right through here for a second. So remember, this is my A value. Alright, my A value was 5, remember. Okay, now, don't worry about, oh, that's A, that's B, you know, that didn't matter so much. What matters is this 5 is horizontal. It's in the x direction. So that means that 5 is going to go with the x's. It's going to go right here. But this is supposed to be A squared, so I'm going to put 25 right here. Now, this B value, this 3, is vertical. It's in the y direction. So you knew that 3 is going to contribute to the y part of the equation. And again, this is B squared, so it will be 9. Okay, so if it's in the y direction, it goes with the y. If it's in the x direction, it goes with the x. It's simple. Okay, so there's your equation. Now, we really didn't need the 0, though, because, you know, it's a 0. So I'd be happier if it were written like this. Okay, that was number 7. Okay, let's move on to number 8. Write the equation of the hyperbola with the following asymptote. Okay, well, there's more than one possible answer, but when I was explaining a previous problem to you, you see the y plus 1, okay? So hyperbola is going to have something minus something, okay? And then it's going to equal 1. Now, these two things, like the y plus 1 and the x minus 3, they're going to show up in this equation. So it could either be here, you know, x minus 3 and then y plus 1, or it could be the other way around. We don't have enough information to know any better than that. Now, so let's see, and they will both be squared. So it's just a matter of what's A and what's B. Okay. Now remember, this is the slope. So this is the rise, and this is the run. Okay. So since this is the rise, that means this is a y value. Since this is the run, okay, because I'm talking rise over run. You know what I'm saying? So this is a y value and then an x value. Okay, rise over run. So the run, so that means this 3 is an x value. Okay, so this is going to help me know what's going to go down here. So this 2 is a y value, so it's going to contribute to the y side of the equation. And this 3 is an x value, so it's going to contribute to the, whoa, I meant to put a 3. This 3 is an x value, so it's going to contribute to the x side. Alright, so this is our A and our B. So this is A squared, though, so it will be 9. and this is b squared right here, so this will be 4. Alright, so this is going to be one form of your equation. Alright, it was either going to be this, or the y could have been first. It could have been y plus 1 and then x minus 3. We don't have enough information to know if it's vertical or horizontal. Okay, so either way would have been good. So that was number 8. That's how you do number 8. And that is the end of this video. Which is good because I just went over an hour. So this better be the end of the video. I hope you found it to be helpful. I'll try to be helpful, not hurtful, as much as I can. And just make sure you can do every problem on the video by yourself. If you copied off of me, you weren't learning just then. Alright guys, I will see you on the next video.